Welcome to Lesson 2. This is our supply curve. Our objectives in this lesson are to understand how the quantity produced changes as a function of price. We're also going to compare price to the quantity produced or supplied using a supply function, and then we'll solve some supply price problems given different supply functions. And I want to draw your attention to this graph down below. That in this graph, unlike how we were doing it with the demand curve, price is on the vertical axis and quantity is on the horizontal axis. Typically, our independent variable is always on our horizontal axis, and our dependent variable is on the vertical. But that's only when we have a causal relationship, meaning that whatever's on the x-axis is causing change to the y-axis. But with supply and demand in economics, this is not always the case. There has been debate about that, but historic quantity has always been on the x-axis because that's where it was originally drawn a long time ago, back when the supply and demand curves were drawn. But basically, price does not cause quantities and quantities do not cause price. So in reality, there is not an actual causal relationship between price and quantity. In fact, the relationship has to do with supply and demand. Price and quantity are changed or are caused to change by our supply and demand curves, as you will see when we start our third video between supply and demand. So again, let's think. If a business produces a new product or they're willing to supply a new product, how many items should they produce or supply? What factors play into this decision? Well, for now, we are just looking at the supply curve. So if we think about on our supply curve, what would influence how much we supply? Well, hopefully you said price, right? We'd supply a lot more if we were paid a much higher price, and we'd be willing to supply not quite as much, in fact a lot less, if we weren't paid as much. So again, graphs can really help us to visualize this. Depending on price, more or less quantity will be produced. Here's our supply function. Again, it can be very different from one graph to the next. It can be a different type of function, anywhere from a quadratic to a linear to a rational function. But basically, our supply function compares our quantity produced or supplied with our price charged. Graphs can be used to model these trends, but in this case, remember now, we don't have an inverse relationship like we did with demand. We actually have a direct relationship. A low price will give us less quantity produced. For a higher price, we'll be willing to produce more or supply more. Let's look at an example. So let's look at a quadratic this time. The supply produced for a product is given by this following supply function. Notice we do have a quadratic. If the price to be charged is $4, how many units will be produced? Well, that's an easy one because all we have to do is plug in $4 into our equation and solve. So, what will be the quantity if our price is $4? How much would we be willing to supply if we were getting paid $4 per item? In this case, to figure this out, all we would need to do is simplify this equation. So we would, of course, do our exponents first. Be careful of your order of operations. So that would be 16. We can multiply these to get 8. Now we can multiply these to get 64. And then we add 8. And we determine that we would produce 72 units. So what is that saying? At a price of $4, we'd be willing to supply 72 units. Let's now look at part B. If the units to be produced are 90, what price should be charged? So now we are wanting to produce 90 units, but at what price in order to make sure that we are supplying what people will purchase? Well, there's 3 ways we can solve this. Now, if we think about this problem, we are now producing 90. Where would that go? Would that go out here in the quantity, or would that go here for P for price? Well, since this is a quantity, we would need to put 90 here. If we do that, we would have an equation 90 equals 4p squared plus 2p. In order to solve that, we have to use one of our three strategies on how we solve a quadratic. Now, first of all, when we're solving a quadratic, it needs to be set equal to 0. So we need to move the 90 over to the other side. When we're solving a quadratic, what we're really looking for are our x-intercepts, or our zeros. So that is why we set it equal to 0. Okay, our first method is here, using the quadratic formula. If you remember the quadratic formula, and you can write it down right now if you'd like to pause the video, but we have negative b plus or minus, which gives us really two equations. The square root of b squared minus 4 times a times c. Being careful to do your order of operations correctly, we would multiply the negative 4 times whatever a is times c first, before we subtracted it from our b squared number. And then that's all divided by 2a. So the hardest part is making sure that you are careful with your signs and that you're following your order of operations. In this equation, our a is our coefficient of our p squared term, or x squared term. Our b is always going to be the coefficient of just the x term, or in this case, our p term. And finally, c is always your constant term, making sure to include the sign with it, negative 90. Now this is a quadratic, so you should get two solutions. We should get the same number of solutions as the highest degree in our polynomial, so we should get 2. Most likely we're going to get a negative solution and a positive, which makes sense. What price should we charge? Should we charge a negative? That wouldn't make sense, so we would eliminate that answer and choose the positive. Now the second way that we can solve this is by graphing. If we were to graph in our graphing calculator, and we would need to put x's in for the p's so that it recognizes the function. But if we graphed 4x squared plus 2x minus 90, we would get a graph that maybe looked like this. It opens up and it's a quadratic. Here's our negative x-intercept and here's our positive. The one we would choose would obviously be the positive. When we're working with supply and demand or other real-world type problems, we only want to look at the quadrant 1, which is right here. The rest of the graph is there mathematically, but it doesn't make sense for what we're doing. So we really are only interested in what's going on in quadrant 1. Therefore, whatever the answer is here is what we would choose. Finally, our last step would be to factor, or our last way of solving, I should say, would be to factor. And we would do a grouping type factor. And if you don't remember that, I'm going to do that here today so that it refreshes your mind on how to do that. Okay, so let's go ahead and factor. When we factor, we need to use grouping. When we group, we need to have an even number of terms, and there's 3 here, so we need to have one more term. So what we need to do is just break this middle term into 2 terms so that we can put one with the 4p squared and the other one with the negative 90. The problem is, how do we do that? So in order to do that, what we do is we make an x. And this just helps our brain to figure out how to break this up. Always what goes in the x is that we multiply the coefficient of the first term with the constant term. So that's negative 360 goes up here. In the bottom of the x always goes our middle coefficient of 2. Notice there's no variables in this x, just our numbers. Now we have to ask ourselves, okay, what times what is negative 360 that adds to be 2? It seems difficult, seems hard to do, but we can use a calculator to help us. All we have to do is take 360 and just pick some number that goes into it. The first number I thought was 12, so I divided it by 12. And it went into it 30 times. Well, 12 times 30 gets us the negative 360, but definitely does not add to be 2. So I ruled that out. I needed a higher number. The next number that came to me actually was maybe 18. So I looked at 360 divided by 18. And I got 20. And then I think, 18 and 20 definitely can give me 2. So I went ahead and I wrote 20 and 18. Now, how do those get me 2? Well, I have to subtract. And I need positive 2. So which one of these needs to be negative? And I'm going to choose the 18. So 20 times negative 18 gives me negative 360. And when I add those together, I definitely get 2, because 20 plus a negative 18, or in other words, 20 minus 18, gets me the 2. Well, now I know how to split up this middle term. So I can split it up into 20p minus 18p. No matter how you split it up, it still needs to sum to give us the middle term. Okay, now I can write the rest of my equation back out here because nothing is changing except the middle term. At this point, I have a quadratic that is now separated into 4 terms, so I can group the first 2 together, and then I can group the second 2 together. And now I'm just going to pull out greatest common factor. So what goes into both 4 and 20? Well, that would be 4. What goes into both p squared and p? That would be p. So 4p squared divided by 4p leaves me with p, and 20p divided by 4p leaves me with just 5. Same thing here. What goes into both 18 and 90? So the first thing I would try is, because it needs to look like this, so I would assume it would be 18. So let's try 90 divided by 18, see if that works. And it does. It goes in exactly 5 times. So I want a plus here, so I'm going to pull out a negative 18, which would leave me with a positive p and a positive 5. And that was my goal. I needed, in my first group, to have the same factor p plus 5 here as I did in my second group here, and I do. So now I can do my last step in grouping. What's the same in the first as the second? Well, that's p plus 5. And then I just write what's left. Well, 4p is left in my first term, and negative 18 is left in my second term. Great. In order to solve, I just set each of these equal to 0, and then I can solve. So, p plus 5 equals 0, subtract 5, and p equals negative 5. Well, negative $5 doesn't make any sense, right? That's this point out here. So we're going to conclude that this is not a solution. Let's go ahead and try the second set here. So let's try this. 4p minus 18 equals 0. I'm going to add 18 to both sides, and I would get 4p equals positive 18, looks better. Then I'll divide both of these by 4, and I will end up with p equals 18 divided by 4. You can do that in your head, or you can use your calculator. Remember, we're dealing in dollars and cents, so we don't want to leave it as a fraction. So we get $4.50. And that sounds more reasonable. So if we are willing to supply 90, what price should we charge to do that? Or what price should they pay us? And that would be $4.50. And again, remember, we could have got that from our quadratic equation or from graphing on our online calculator, but that was just a sample of how to factor. We're almost finished. Let's look at one more portion. Let's look at part C. At what price are there 0 units being produced? So, at what price are we not willing to produce any units? Could be 50 cents, could be $1, or it could be $0. The way to figure that out then is to plug in a 0 here under our quantity produced, and then solve our quadratic. Again, we can do the same thing we did before. We can graph it, we can use quadratic formula. Notice that C would be 0 because there is no constant term. We could even factor. But look, it's already in a group of 2. So let's just go ahead and say this is grouping already, and we're going to pull out a GCF. What goes into both 4 and 2? Well, that's 2. What goes into both p squared and p? That'd be p. 4p squared divided by 2p is just 2p, and 2p divided by 2p is just 1. Okay, now we're going to do like we did last time and set each of these equal to 0. 2p equals 0, divide both sides by 2, and 0 divided by 2 is 0. Well, that makes sense. At $0, we would not be willing to supply anything. Makes perfectly good sense. How about this other part? 2p plus 1 equals 0. Subtract 1 from both sides. Oh, we can already see we're going to have a negative answer. So remember what we said. We're not interested in negative answers because negative 50 cents is not in quadrant 1, and that's not something we would deal with, negative prices. Okay, let's wrap up. So remember that just like demand functions, supply functions can have different forms too. It doesn't necessarily have to be linear. It can be quadratic. It could be a radical function. It could be rational functions. So as long as we understand how to answer the questions that are posed of us, where would we plug in the numbers? Again, it doesn't matter what type of function is, the process is still the same. The other thing to take away from this is that we're only dealing here in quadrant 1. We don't care about any of the other quadrants. So we're looking at our supply curve in quadrant 1. At this point, hopefully you can understand how the quantity produced will change depending upon the price. We can also compare price to quantity supplied using a supply function and solve problems given different functions.